All right, it is another Wednesday and another Entity Framework Community Stand-Up. I'm Jeremy Likness. I'm here with Arthur.
Hi there.
And Shay.
Hey, everyone.
Members of your EF Core team. And today we have a very themed stand-up. We are doing all things Azure Cosmos DB. So let me pop in on some original artwork that I put together.
Sorry, I was supposed to be doing this.
No worries. So I'm calling this one Unicorns in the Cosmos because we are talking about what the EF Core provider for Azure Cosmos DB is, why you would be interested in using it. We're going to go through a little bit of the logistics around how it's used. We're going to talk about differences between document databases and relational databases. And we're going to look at a future roadmap. What is coming in EF Core 6? All of that ahead in the hour to come. So let's jump off here if I can get to the right place. Okay. So the first thing I wanted to do is recap on the survey that we conducted at the end of last year and talk about some of the feedback we got around Cosmos DB. So it was ranked about 6th place amongst providers. There's no surprises. The relational providers like MySQL, SQL Server, and for testing, which is what most people use it for, right? In-memory database came up, but a solid 6th place for that. What's even more interesting, though, is the most requested provider was MongoDB, which is also a document database. So that gives us a pretty strong signal that developers are interested in using EF Core with document-based databases. 1 in 3 people who responded said that they were evaluating whether to use Azure Cosmos DB or not. And 7%, this is out of all respondents, so it's about 1 in 14, said that they would use the EF Core provider if it had more features. And we'll talk about kind of what those features are. I don't know, Shay or Arthur, did you have any thoughts or comments before I move on?
So I would just say, we've had a lot of discussion about whether or not we should be doing a Cosmos DB provider or whether we should be focusing purely on relational. And I think that's one of the reasons we've done this survey and we've done this market, this customer research basically. And I think there's still a case to be made on both sides of the fence. But it's very clear that people are interested and people are using it and people want to use it more. And so that's from our perspective, that's why we've decided to continue with this and move it forward. But it's still very much let's discover where to go, and that's kind of the rest of what we're talking about today. It's like, where do we go next with it? So I think we'll talk later a bit more about the differences between a relational and a document database and what makes sense and what doesn't make sense. Obviously, not everything makes sense, but there's enough. I think there's enough that does, that it makes sense to do it at least.
Yeah, I think that's actually a great segue to this next piece I captured. So when we talk to developers who are using it, these are the reasons that we're given. It's easy to set up and get started. We'll take a look at what that looks like. They're familiar with the API. So a lot of shops use EF Core. So when they're adding Azure Cosmos DB, they'd like to use a familiar API. And then there's the multi-use. We have a organization within Microsoft that has a very high volume ingestion service. And it takes in data and fans it out to a SQL Server and a Cosmos DB database. And their solution for doing that was an Azure function using EF Core, because they basically just use a data context configured for Cosmos DB, a data context configured for SQL Server, and pull the trigger on that information. I think the real power of EF Core comes in the DB context, right? And the fact that it has a change tracker built into it. It handles optimistic concurrency. There's actually a lot of tools, even as I explore the API surface area more and more, that just anything you've probably wanted to do with data, for example, copying a DTO into another class, there's facilities for that. So that's another reason we get heavy use. Any thoughts from the team?
Yeah, so I'd like to step back to when we were talking about EF Core. So this was back in the days when Diego, Rowan, Andrew Peters, myself, and some other people were talking about EF Core. And one of the things we talked about is, does it make sense to do a relational database and a document database? And this slide here really shows that there's lots of patterns. There's lots of APIs, there's lots of things, ways of doing things that people are familiar with EF Core that are nothing to do with a relational. They're nothing to do with the fact that it then gets mapped to a relational table. For example, change tracking, unit of work, and things like that. And that's actually really why we thought, this isn't really just an object relational mapper. It's you have a database and you want to then do a bunch of patterns and things that make sense on top of that. And I think that holds out. And this slide is kind of, calling that out, that there's lots of things that aren't really about the relational mapping that you do with the data. And it's still useful to have tools, as Jeremy says, that can do all those, like DB context with all of this stuff. So this is kind of why we did it in the first place, actually. In fact, why one of the main reasons to do EF Core over EF6 was to not be tied to just doing relational databases. So it's kind of cool seeing this all come together 5-6 years later.
Yeah, it's been a journey. I actually have this quote from 2 years ago from Julie Lerman in MSDN magazine. And first thing I noticed is I didn't have to write all that extra code. I just provided a connection string and was good to go. So it might not be quite as simple as that, but it is. And in fact, one of the things I wanted to do was walk us through what it looks like to perform some operations with the V4 SDK, the latest Cosmos DB SDK, and the latest EF Core provider. And what I did for this is I took the getting started to do app that comes with the SDK, and then I converted it. Then I converted it over to use EF Core. And this is what it looks like. So this is initializing a client. And in the SDK world, we've got the Cosmos client, and you pass the endpoint and authorization key. With Entity Framework, you have a DB context, and that context can be used with multiple providers. It's not Cosmos specific. So if I'm using SQL Server, I might pass a SQL Server connection string. If I'm using Cosmos DB, I simply tell it use Cosmos and pass the Cosmos specific data. That's what those two look like. This is creating the database. There's an API for that built into the SDK. In again, Entity Framework Core, regardless of the database you're working with, we have this ensure created in async. And this is actually useful for me a lot for demos. If you're managing a database, you're probably not going to be creating it on the fly like this, but for demos and for test purposes, knowing if it exists or not and being able to populate the database and update it is important. Creating the container, this one was fun for me because in Entity Framework Core, we create the container implicitly. So by convention, we create a container for you. You have the ability to override that. So in your model configuration, you can say, I want this specific container, but we do some of the things out of the box to make it easy for you.
So going back to that last slide, that's more generally in EF Core, we have this idea that we do things by convention for you. So this is for relational databases as well. And the important thing that Jeremy said there, you can override this if you need to. So that's the approach we take. We do things by convention, but we always want to provide a way for you to override those things and do, and do your own thing where what we're doing by convention isn't quite right for you. So when you see it does it implicit for you, don't be afraid that then you're not going to be able to have access to what you need. Or if you do find you don't have access to what you need, file an issue on us and we'll change it. I think we had one for getting the container ID easily or something like that. I can't remember exactly. Client ID it might have been. But anyway, the idea here is to give you full access to to the underlying container and everything you're doing on Cosmos and not hide it from you, but to do common things implicitly by convention. And this is a great example of that.
Yeah, I think it's like the 80-20 rule where sometimes you get a tool that covers the 80% scenario, but the pain is in the 20%. And that's what I like about EF Core is it's designed to give you access to that 20%. So it's not so painful. What doesn't come out of the box, you can still get access to. So this is a read. And one of the important things to note is if you've worked with Cosmos DB, a huge part of performance and, quite frankly, cost is partitioning and how you partition your data. So being able to specify a partition key is very important. In the SDK API, you do it explicitly there. In the EF Core 5, we have configuration on the actual entity that you can implicitly specify how to get the partition key. But of course, when I'm loading something new, there's nothing for it to look at to get that from, so I have to provide it, and I can use this with partition key extension to provide that partition key. If we're dealing with inserts, and this is where I think the two, the SDK and EF Core start to diverge a bit. The SDK is very much focused on fine-grained operations. So I'm going to do an insert of this entity. I'm going to do a read. I'm going to create a query. With EF Core, we've got a DB context that tracks an object graph. And we may have multiple entities that we're keeping track of. We may have multiple nested items. And so the whole concept here is that you bring in data, you make manipulations, and then you call save changes. Pretty much every API here you're going to see save changes is the way to do that. So here we're just saying, hey, EF Core, there's a entity that we want you to be familiar with that we're adding to the context of the system here, and now save changes. And it recognizes, hey, here's an entity flagged as added, and then it saves it.
I think, yeah, I have one thing I've always loved about the way EF Core does this. So the unit of work pattern that you're seeing here on the EF Core side, first of all, you're doing an add. Add doesn't actually do anything. It doesn't go to Cosmos or to your database and insert anything at all. It just accumulates these things. You can add multiple things. And then when you do save changes, all that gets sent in one go. And that's something that I think is great. It encourages let's say a very performant style of programming by default. So if you're not thinking about all this kind of stuff, round trips with the database and making stuff performant. If you naively write the code of the SDK above, I'm not an expert on how the SDK works, but I strongly suspect you're going to be doing a round trip to the database, to Cosmos every single time. Whereas with the EF Core version here, because you're using unit of work, it's going to by default steer you in a direction where you're accumulating those changes and then sending them in one go. So doing just one round trip. And I think that's an awesome thing. I love it when it's what we sometimes call inside the team a pit of success. It kind of like steers you. If you don't know anything, you've not read any documentation, you've not thought about perf, you're going to end up doing like the right thing in terms of perf. And that I think is an excellent way to design APIs.
I love that too. And I love what I call kind of ambient manipulations, is for lack of a better term. I love that I can take that context and then based on triggering from maybe I added a record and I inspect that and I want to have a side effect from that, like a audit or something else, that instead of me worrying about did it insert yet, did it not insert, is there a key, is there a relationship, I can just stand up the object graph, hand it off to EF Core, and EF Core will say, okay, I'm going to do everything necessary to make this happen. So it's very nice. And we'll see that in a demo in a little bit, how that works. So that's insert. So query is another place where there's a pretty significant difference between the two. And that's because the Cosmos DB supports multiple APIs, first off. So there's MongoDB, there's a graph, there's a table storage API. The one that we work with is the SQL API. It made sense because we already have code that parses to the SQL dialect. And so working with that. In the SDK, this example, you're basically building a query with a string. With the EF Core 5 DB context, we provide an iQueryable that you can then use link, and that link gets translated. So basically, we're going directly off that entity definition, specifying the filter, and then when we call toList, that actually executes the query and allows us to begin iterating through it. Update. This is another favorite one of mine. There's no explicit operation you have to do to update. You simply manipulate your graph. And if you've loaded it and you have multiple levels of detail and you alter one node on that graph, it's smart enough to save that one document that contains that node. So this will go through whether you've added, deleted, changed. It's going to capture all those changes and sort of, I hesitate to use batch because there's a batch feature, but it batches up the operations and sends them all out in one go.
It's, I think it's worth pointing out here that, again, this is exactly the same as you can do with a relational database, but as is also true with a relational database, if you have disconnected entities, you can still do the thing where you just bring it back and you call update and it's going to write the entire thing back. Not as efficient, just like it isn't with relational databases, but super easy to do and very reasonable for a lot of simple cases. So both those patterns that you kind of know that people know from the relational world also translate well over into the Cosmos world. Yeah.
And speaking of which, disconnected entities. So this is showing an example of a disconnected. If I had loaded the family to delete, I would just do context.remove and save changes, and it would be a done deal. This example, I'm basically disconnected, so I haven't loaded the family. So I'm basically creating an entity, attaching it to entity framework, letting it know that, hey, we want this entity to be deleted and save changes. So there's multiple approaches to do this. I could have also attached it, removed it, and so there's a few ways to get to the end result.
So we have a question here. Let's bring it up on the screen. Jeremy's example of Cosmos DB query looks susceptible to insertion injection attack.
I think they're talking about this one. And so I guess my response to that is the SDK does use parameterized queries, so it's not completely pulling it. Now this one is hard-coded because it was the to-do kind of getting started. We would likely not hard-code Anderson, right, in that query string. So I probably could get a better example for the SDK because the SDK does support parameterized queries, just pointing that out.
I don't think it's fundamentally different than how you would work against a relational database. If you're on the low level kind of doing your own SQL, you have to think about parameterization, and it's on you, obviously, to make sure you're not doing anything funny, obviously.
Sounds good. Well, let's jump into a demo and take a look at a application that I built that's on GitHub that you can work with. I'm actually running it with the emulator. I think that's important to know that when you're working with this in the development lifecycle. I believe there's plans to have a cross-platform emulator. Right now, I think it's Windows only. I don't know.
They've actually released that's really new, Jeremy, but they actually have, I think it's in beta, there's a Linux emulator now.
Nice.
Which makes me very happy.
Yeah, it makes me very happy too.
Have you tried it, Shay?
I haven't, no. I haven't had time to try it out.
If anybody's tried it, let us know how it works.
Yeah, I used to have to, and nobody really cares about this, but you used to have like a VM where you run the Windows emulator and then have to route, your Linux to your Windows VM and all that kind of stuff. So all that is better.
Okay, so this is what I call Planetary Docks, and I am an aesthetically challenged developer, so bear with me on the UI design. The point is to showcase the EF core functionality. This has some things like type ahead, like I can put A, and then you'll see I get a convenient drop down of authors. In fact, we have our own Arthur here. So he authored identity model customization in ASP.NET Core, and I'll zoom in here a little bit.
I wish I didn't author that. Sorry.
All right. Well, we're going to look at and figure out why. So I'm going to come in here. Now, this is poor contrast. I know I made it computery, but this is the markup behind the document. We can show the HTML that Markdown converts to, and we can even show a preview. And this also has an audit history. So that's interesting because I'm going to show you this in the code base. Now, this only has one audit, but let's go ahead and edit this. And let's make Arthur happy by deprecating it. And we'll save that. So now we see in the title it's deprecated. We can look at an audit history, and we can see that we have 2 audit histories. And in fact, we can even drill into this previous copy of it. It's telling me I'm viewing an archive version. Click here to return to the current version, so I can see that snapshot in time.
Jeremy, is this a show about Cosmos, or are you trying to push your new blogging platform here for everybody?
Yeah, right. So, you know,
looks so amazing.
It's funny because when I go for demos, I try to get data as easily as I can. So a lot of times I'll use the type system and recreate types and methods and properties because it's so easy to populate. This was easy because I wrote a parser that walked through the ASP.NET Core docs repo and pulled these in, and then Blazor makes it easy. We could have a whole other show on how awesome Blazor is, but yeah.
Absolutely.
So
we should have a show on AF Core and Blazor. We need to do that soon.
That's actually true.
Yes, we will put that on the list for sure. So the other thing I wanted to show is these searches actually happen a little differently based on if I have a tag, and let's say for Blazor, and then we'll search for that. So I get 428 documents. Now let's pick this alias here. Looks like they've authored quite a few, so I'm going to further subfilter, and we'll search on that. So just ignore that. We didn't see that happen. And then hold on, let me, you know what I didn't do? I didn't do a reset button, but let's pick a obscure topic like, well, not obscure, but let's say SQLite. What documentation exists for that? So this is actually doing a text search now and pulling up parts that have that. Okay, so I think that's enough of showing the demo. Let's take a look at code, and I'm going to stop this so that I get some of my memory and CPU back. So I'm obviously not going to go through all these tons of Razor pages and things like that, and don't worry, my font size is high. But let's look at kind of what some of these entities are. So I've got this iDoc summaries. Let me talk about iDoc summaries. This has a list of document summary, and if we look at document summary, this is simply a UID, which is the unique identifier of the document, a title, and an author alias. So the idea behind a document summary is it just gives a little bit of summary information about a document. So the author entity has a list of the documents that they authored. And this is done for convenience so that the search can be incredibly fast. If I'm looking for Arthur's documents, I can retrieve them quickly. The same thing with the tag. You're going to see the tag is also an iDoc summaries, has a tag name, and then it has its summary documents. The other interesting features are the document itself. So it's got this UID, title, description, published date, markdown, HTML, author alias. Now notice the author alias is just a string here. I'm not pulling in the whole author entity. I just need the alias, and I have all the information I need for that. Same thing for the tags. And then knowing that, we can look at the document context. And this is where it gets interesting, and I think we can start to have some discussion. And I'm actually going to, let me see, I'm going to pull this into another window. There we go.
So we have a question on, let me put it up there. Why do you use interface for iDocument? Do you have multiple iDocument implementations somewhere?
So I'm using iDoc summaries, and I both have the author and the tag use the document summaries. Oh, are they asking? I don't think I have an iDocument, do I? No. It's iDocument summary. So both the author and the tag have summaries.
Makes sense.
So basically, if we look at the context, this is where, you know, we can start to have some discussion about differences. So I've got, this is my favorite way of doing magic strings without magic strings. So partition key and meta, those are just names. And then notice here I'm hooking into save changes. Now, we know from other shows that there's multiple ways to sort of intercept things that happen. We have a middleware approach with interceptors. We have an event-based approach here. So I'm using the event-based approach. I'll talk more on that later. Here's my DB sets. I'm exposing audits, documents, and tags. Where it gets interesting is when we actually look at the, ignore that for now, when we look at the model creating. So here I'm creating the document audit. That's the history of the documents. I'm telling it has no discriminator. So in Cosmos DB, you can store multiple types in the same container. And by default, Entity Framework will add a discriminator property so that it can distinguish between those types. If you know that a container is only going to have a single type, you can avoid some of the overhead of having that property and that logic by telling it has no discriminator. And then it simply won't add that property. And we'll see what that looks like in a second because I'll navigate over to the database. Here I'm giving it its own container. So it's going in the audits container. I'm partitioning it by document ID. So the history of each document will be in its own partition, which seems logical because I'll typically be querying within a document's history if I'm finding out things about it. That key is the composite of the unique identifier for the audit entry and the partition key. That's the doc key. All right, so that's document.
So, so in that case, you've got a partition key that is a bigger space, and then you're using it with another ID, so you narrow down that space to a single entity, right? So that's
Correct.
why the partition key is kind of broader than the individual identity, the primary key.
Correct.
Right.
And with Cosmos DB, there's a performance hit and also a cost associated with jumping partitions. So the partition strategy has to be something to optimize against having to do cross-partition queries. So the idea here is I'm not querying the audit history except within a specific document. So those can basically exist in their own partition. So if we look at documents, they're also stored in their own container. The partition key is actually the document ID, and we can take a look at this, but there's actually an article that talks about that strategy of using the ID as the partition key. It seems what's the word I'm looking for? It seems opposed to the advice we just talked about. But if there's no property that provides an even distribution, and these documents can be pretty much anything, then it may be advantageous to take this approach. I'm also noting that there's a concurrency tag, and that's one thing I forgot to demo, but this demo has concurrency built in. So if I update a document in one tab, update the same document in another tab, and then click save on both, one of those will actually throw an exception and tell me the document has changed since I last saw it. The other piece of this is...
So I have a quick question about the unique identifier. Why is it a string rather than a GUID?
That is a great question. So in this case, the documents in the repo come with their own unique identifier, which is a human readable string. And it's guaranteed unique across the repo. So it was just easy to use that rather than create a new artificial key for that. Another question might be performance-wise. Is a string or a GUID going to be more performant or less performant? And that I don't know the answer to for Cosmos DB.
Well, I think it's important to so Cosmos, at the end of the day, what's happening is JSON documents are going back and forth. So at the end of the day, even if we put a GUID on the .NET side, I'm assuming, again, I'm an outsider to Cosmos, but I'm assuming EF Core would simply send a string in the JSON at the end of the day. So I don't expect there to be any sort of fundamental difference between the two. It would be purely a question of how you interact in C#. Is it with a string or a GUID? But behind the scenes, the same JSON document would get thrown back and forth.
Right. So this is something that I'm hoping goes away in EF Core 6, and we'll talk about that when we talk about features. But basically, I have a primitive collection on the document of tags. By default, that's not supported by EF Core to serialize and deserialize that primitive collection. So I'm just providing a value converter, and I'm basically just serializing the list of tags out and deserializing them coming in. So this is a way to work around that limitation for now. I know that there is a item slated for the 6.0 milestone that addresses this, so that this would go away. And then the other thing I wanted to show you, and this is a pretty simple example of this, but the tag owns several documents. And right now, I have to explicitly tell EF Core what EF Core, based on its relational legacy, is going to think about is if we have a relationship of complex types, we're going to assume that those are probably translated to tables with relationships. In a document database, the implication is that the entire graph, so I give you a root node, the entire graph is part of that document and should be owned by the document. So right now I have to explicitly tell it that it owns many documents, or it'll try to put the documents in as separate documents and actually cross-reference those, as opposed to this lets it know that there is ownership and it's serialized with the document. Yet another thing in the 6.0 roadmap that we're looking to do implicitly to recognize that you're using a non-relational provider and have implicit ownership as opposed to requiring explicit configuration.
So I'd like to talk a little bit about the owns APIs. So the owns APIs that we added, I don't know, 2x, so quite a while ago, were intended from the beginning to be a way of defining aggregates such that regardless of whether it was a relational database or a document database, you could say, this is these collection of entities I want to treat as a single aggregate with a root in a kind of DDD-like way. And that maps very nicely to documents in a document database, but you can also map it in a relational database. I think the key here is like going back to the conventions versus configuration. For a document database, you really want this to happen very commonly. It's normal to map these things as an aggregate in a way that isn't necessarily the case in a relational. So I think what we're going to do with the feature that Jeremy said is we're kind of changing the conventions for when you're building a model for a document database to be more aligned with what you expect for a document database. But that doesn't mean that you can't go back and do other things as well. But it's kind of like aligning those things to work better for the document backend. You may have also seen the owned APIs used for value objects. It don't work very well for value objects, so we won't go into that in detail here. But that was kind of a try to reuse the same design in two places, which I think has not really panned out like we hoped it would.
I'd like to add one more comment here. So we're talking about the owns concept as like a conceptual thing. So what does it mean, for example, when you apply to a relational database? One of the options, because I'm guessing people aren't necessarily aware of this feature, one of the ways to map an owned entity in this way is if you have, let's say, a normal relational table, then an owned entity can simply be additional columns inside that table. So we basically do what we call row splitting or table splitting. We have one database row, which is going to contain some columns for the main entity, let's say, the root one, and others for the owned entity. So you kind of like combine those two into the same row, which conceptually is maybe a little bit similar to, like a document in a document, database where everything is contained in the same thing. Here it's the row. And I think, once again, I like this example because it shows you that you have this conceptual thing happening in EF Core. We talk about, ownership, and we talk about it in a way that applies to both document databases and relational databases in radically different ways because they are different databases, but the conceptual thing is the same, and the logic and the concepts work the same way. And I think, once again, it's a nice strength of EF Core.
Absolutely. Another thing that I like is I'm going to show you this tag model is, let's see, tag model, blah, 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 goes to container, meta. Where is the tag model to container? Yeah, to container meta. So both tags and authors are in the meta container. And I wanted to show that example of having different schemas inside the same container. So let's pop over to my emulator and look at the actual Cosmos DB database. So let me zoom in here. So I have my audits, and if we expand that, we're going to see we have items, and those items are unique IDs for each audit snapshot, a partition of UID for the document. So this is a UID per document and then multiple IDs per audit entry. And then we can take a look at one of these example entries, and we can see a whole lot of data, because this is basically a serialized snapshot of the document inside that. What that serialized snapshot looks like, we can come over to the documents table, and we can see, for example, we have our UID, which is our unique identifier. We have our author alias, the description. Here's the unique concurrency token. Here's the HTML, which is a big blob of stuff, right? And then we'll have a similar thing for Markdown. And then we have publish date. Notice that the tags is just a serialized array of what the tags look like. And then we have title ID, and then there's some internal properties that Cosmos DB actually keeps track of, like a timestamp for when this was last updated. In fact, that's actually interesting because Cosmos DB has a concept of time to live. So you can actually specify that a document only exists for a certain period of time, and it'll auto delete that document out. And one of the feature requests that we're looking at for 6 is being able to configure that time to live, which is very useful in high volume. For example, I'm ingesting data and storing it to aggregate and analyze it, and that data basically times out because it's just the aggregate that I'm interested in. Now let's look at the meta container. So the partition key is just telling me which type it is. So all the tags are partitioned together, all the authors are partitioned together. The ID is going to be the partition key and the unique identifier. So the ID needs to be unique across the container. So if I had a tag with the same name as an author's alias, that would create a problem. But by discriminating like this, it ensures that I have a unique identifier. When we look at a tag, it basically has its summary of documents in it. Now there's a service that sits on top of the DB context that does this synchronization. And this is one of the things that becomes a decision point for whether you're going to go with a relational or a document database. Because in a relational database, we could create the relationships between these and they're always up to date. With a document database, if I want to keep these in sync, I have to manually synchronize them. So I have to have logic that says, if I change the author's alias on a document, I need to go to that author's entry and remove that document from their summary tag. So I'm going to show that in code in a second. But first, let's look at the positive side, which is what the query logic looks like. And I'm going to jump into a service that is query documents async. And so basically what we can pass in is some search text, an author alias, and a tag. Here I'm creating the DB context. If I have an author alias, I'm grabbing the author right here, and I'm adding it to the set of results. Now what's important here is if that's the only thing I search on, then we're pretty much done. It'll just fall through and it has the list of documents. So it was just one transaction to load that alias, and we get the full summary that we can drill into. If you happen to have a tag, we do the same thing. We grab that tag entity, but now we have to make a decision, because if you're doing the alias and the tag, we just want the intersection. So which documents have both the alias and the tag? Otherwise, it's just the full tag set. So again, here we're either doing one read operation or two. alias and a tag. The only time it gets a little more complex is if we're doing a text search, because now I have to do a full, here's my link query. I'm looking in title, description, and markdown. So I'm doing a full text scan. And then I'm basically taking those results and then further refining them based on if there's an author or a tag. But this allows me to have very efficient search logic. Instead of scanning multiple documents saying where the alias is someone's name, I take the work up front when I update the document. I take the effort to update the summary for the author and the tag. And then in the search, which is going to happen far more frequently, I can have just a really fast operation to pull back those search results. And let me talk about the save strategy. So when we save a document, I've got a couple methods. Let's just look at handle tags async. So this handles the tag logic. So I basically come in here. So the idea is I've either added a tag to a document or I've removed a tag from a document. So what I need to do now is I need to basically look at what tags were removed. I need to find those tags, and I need to remove that document from the summary. So that's what this is doing. But notice that I'm not actually doing anything with the database just yet. I'm only updating the DB context. So I'm telling the DB context, this tag you're tracking has a documents list, remove that summary, and flag it as modified. And we can talk about the flagging as modified, but basically I go through here. I'm looking at author changed. All of these are just operating on the context. If we look at the update operation for update document, let's do this. This just calls handle meta async, and that's called on an insert or an update. And it just lets the context get manipulated however it needs to be manipulated. And then we call save changes. And when we call save changes, all of those changes will persist. And what's nice is if I have a tag in memory that hasn't had any changes to it, it's not going to apply any changes. It's not going to be a redundant update. So it does it in one succinct operation for me. And I lost the train of thought. I had one other thing I wanted to say, but
well, we have
in a second.
A question. Sorry, it scrolled before I clicked it. This question. Please contrast the ASCII K via ZF Core for soft delete.
It's a good question. You know, I am not familiar at all with Cosmos DB soft delete capabilities.
Me neither.
But I'm going to assume that at least, so EF Core has its global query filters feature, which allows you to say that whenever you query a table, you should, for example, filter out any rows that have, some attribute. So I'm assuming that you can use that feature just as well for Cosmos DB, and it would change your where clauses. It would add like the soft delete clause. So at least at that level, I'm assuming you can use the same tools that EF Core already gives you, just like in a relational database.
Makes sense.
Then a follow-up question on this. Looks like tag removal is lots of extra work instead of having cascade delete.
I agree. I'm doing work up front, right, to manage it, to save on the back end of the queries. So
absolutely.
And that is the trade-off. I could go relational, or I can go document and have these super fast operations that require a little bit of effort on the save transaction. So it's definitely trade-offs to consider.
Yeah, I think that's a general point when we're discussing document versus relational. There's various ways in which in document databases you have to do a lot of things manually, which you would do, which you don't have to do in relational databases, and that is the strength, and that is also the weakness, depending on which way you look at it. Absolutely.
I'm going to do one more thing and jump into the context because I totally glossed over this context saving changes. So this is another feature that is a reason why developers like to use EF Core. Here, when you're saving changes, I just have this generic piece of code that queries the change tracker. That's an API that's off the context. And I'm basically telling it to give me anything it's tracking that's a document that's either added or modified. And when I find something that's either added or modified, I add an audit for it. And that's it. I just intercept that save changes, add those audits, and they ambiently, so to speak, passively, I guess you could say, get saved. And I don't have to worry about developers making explicit code or doing anything special for that. I could use an interceptor to do something similar, but the idea is, again, I'm just adding it to the context, and then save changes is handling all the operations after that.
This pattern of either overriding save changes or using the event or the interceptor and doing things right before they get saved to the database is pretty common. It's pretty powerful feature that people use. It has you need to make sure that it's doing the right thing for you. For example, this is obviously all going as one thing. Some people might want as one, like, I don't want to use the word transaction, but as one collection of things to the Cosmos database. Sometimes you might want audits to go one place and go independently and things like that. And also you may want to use timestamps that are on the database instead of timestamps that are on the client, and that's another place where it can trip you up. But generally, it's pretty useful and powerful way of very quickly just getting additional changes in, like auditing, like Jeremy showed. Nice. I can't unmute you, Jeremy, because you chose to mute yourself.
Yeah,
okay.
So that was a big speech that, no, I basically wanted to show the concurrency check. So what I'm doing here is watching this die. Okay, so basically loading service. Anyway, you know what? I'm not going to fumble around too much. The concurrency is as simple as when you call save changes, you will get a specific exception that EF Core will throw that's a concurrency exception. You can capture that exception, and then you can choose exactly what you want to do. The exception even gives you an API that exposes what properties look like and allows you to load the current snapshot from the database. And I've done examples of applications that will actually show the database field next to the label and say, this is what it changed to. Do you want to overwrite changes or reset or so forth? So it makes it very straightforward.
And that's another common pattern that if you've done optimistic concurrency with a relational database, it's the same when you do it in EF Core with a Cosmos database. Even though the underlying mechanisms are different, I mean, they're actually different for different relational providers as well, but conceptually it all works the same, which is means you only need to learn it once and then you can keep using it, which is great.
Yeah, and in this case, I went really simple. I try to save it. If I get a concurrency exception, I set a flag. And then in the related Razor template, the flag puts an alert bar that says data has changed, overwrite, or refresh. It's as simple as that. It doesn't have to be a extremely complicated solution.
Yeah, if you had to do this yourself manually without EF Core, then you have to go and manually change every single update and whatever that you're sending to the database, and check whether that update actually updated as many rows as you think it should have on a relational database or whatever. It's a lot of work. It's really a lot of work. So I think that's a very persuasive case, I think, for why EF Core is useful for Cosmos as well as relational.
So I've got a quick playbook. I want to get to the roadmap, so I'm not going to spend a ton of time on this, but just when you're approaching Azure Cosmos DB with EF Core, some of the things you need to do is, first off, you need that strategy for databases, containers, and entities. EF Core does not hide the fact that you're dealing with a document database, and you need to think about things like partitioning. It is completely possible to have every single document in one container. That is a valid approach in some scenarios, but there's reasons to have them in different containers. And that is really a Cosmos DB plan that you have to put together. It has nothing to do with EF Core. EF Core will allow you to implement the plan, but that plan needs to be in place.
So I would actually add a step 0 before that, which is before you even plan to use EF Core, make sure that a document database is the right kind of database for the domain and the task that you want to do. It's not the case that if you've got a relational application, you can just say, oh, I can use document database for that, and that will always be the right answer. Very often it will not be. But there are a lot of cases where you can say, oh, for this thing, it looks like documents would be a really good, better way of modeling this. And so then you need to use it. But don't just assume, oh, I'm using EF Core, so it doesn't really matter whether I use Cosmos, Relational, whatever. You still really need to figure out, is the document database the appropriate solution for your particular problem?
And I want to say another word about this to continue on what Arthur is saying. We occasionally get people who are basically try to implement relational strategies on top of Cosmos. For example, if your typical thick query would need to join, let's say, in the relational terminology, join together different documents from different places, like whatever, pull in 5 documents based on foreign keys, so to speak, and so on. You're probably doing it wrong. So that is not where a document database shines. That is exactly where a relational database, because we're talking about relationships. In a document database, you typically model things in documents which are hierarchical entities which contain everything in themselves, rather than create relationships between different documents and join them back together. So this is really what Arthur was saying, that you have to stop at the very beginning, step 0, and ask yourself, which way am I going to go into? And it's really fundamental to it, because otherwise you're going to find yourself with a badly modeled document database that's also going to be very costly, because you're in terms of performance and also in terms of just money cost, because you're doing things which the document database was not designed to do. Very important.
And there are certainly plenty of cases that there's a combination of both, right? So, for example, a link tracker might have a relational database to define the relationship between the shortcode and the links and the marketing stats and whatever, but then activity might be dumped into a document database for analytics afterwards. So
yeah, and by the way, you also have the so it's not also like one or the other. Nowadays, document and relational databases are not just two things, two options. You have a spectrum nowadays where relational databases also include document-like features in themselves. You have JSON support, for example, in most major databases nowadays. We also plan to work on delivering better support for that in EF Core. But regardless, you can have document-like strategies within a relational database. Or you can also use, to a limited extent, some relational strategies within a document database, but you have to make sure that you're choosing, the right place on this spectrum.
So speaking of the right place on the spectrum, that's definitely important right now with EF Core. If you do go to the document side to configure your hierarchies and own entities correctly, so that you're not spreading entries across multiple records, so to speak, that should be just contained in the same document. I'm looking at questions. I'll address some of those when we get through this slide. Use toContainer to specify your containers. So again, EF Core will implicitly create a container for you, but gives you the option to override that. Be sure to use has no discriminator if you're just storing a single type in a container. Partition keys, partition keys, partition keys. I think there could probably be a 6-week course with a certificate at the end on understanding the optimal approach to partition keys. I know data scientists will probably tell me, oh, it's a no-brainer, but there's a lot of different strategies. The nice thing is we've got support in EF Core to specify those on reads, updates. Even if EF Core creates your database for you, it'll create it based on the partition key. Your model builder can specify that. But it's very important because this impacts not just performance, but is probably the single, and don't quote me as a statistic, I don't have a study to support this, but I'm pretty sure that a reason why some implementations are expensive is because of mismanagement of partition keys. And they could be a lot more cost effective if the partition keys were configured correctly.
Oh, go ahead.
And last but not least, for primitives and other edge cases, use value conversions when needed to manage properties. It shouldn't be a showstopper of getting your documents into and out of the database. We've got facilities for those edge cases.
So let's look at question here is about, can we use the same approach when using Cosmos DB to MongoDB? So I assume this means if you already have a MongoDB, can you use that approach when using Cosmos DB?
Which approach?
Don't know. I assume this playbook of what you're doing, but given this is for EF Core, and we don't, I mean, there is a MongoDB provider for EF Core out there somewhere. I haven't looked at it for a long time. I don't know that I don't think it's very up to date, but I could be wrong about that. If we or somebody were to build a MongoDB provider for EF Core, I think it would probably follow a lot of the same patterns and approach, but I'm not an expert on that, so I don't really know for sure.
Yeah, and it's using same EF Core methods. So it's been a minute since I've worked with Mongo. I used to actually work with Mongo quite a bit. I know that it has these concepts of containers, entities, etc. So I'm sure there's quite a bit of overlap between how the API looks. Of course, your queries are JSON formatted, not SQL formatted, so there's differences there. But as far as how the data is stored and comes in and out, it should be probably pretty close. There was another question that popped up, I think, twice. I'm going to just highlight this one. And this is the built-in code for copying to from DTOs. I didn't want to highlight that too much, but there are mechanisms, for example, to take an object and copy the properties wholesale to create an entity with those properties. So it's not a compete with AutoMapper. It's not like a fluent configuration. But if you have a very simple, I have a DTO with a subset of properties and a full-fledged class that has properties of the same name, there's an API that you can use to move those properties over.
So basically on that, you want to go to context.entry, which gives you an entity entry back for, a tracked entity. And then there's a lot of APIs off of that, chained off of that let you go to do various things on it. We also have documentation on it under change tracking. So if you go to our docs and look under the change tracking kind of top level item, there's a bunch of documentation on how to do those kinds of manipulations. They're also very similar to what was in EF6. We originally designed them in EF6 and basically just ported that code to EF Core. The underlying implementation is quite different, but the concepts are the same. So if you're used to doing that from EF6, then it's the same. But like Jeremy says, it's not an AutoMapper complete. It's about basically manipulating and working with your tracked entities in the change tracker.
Yeah, so you've got like current values, and then I can clone here and get another set of values, or I can do toObject and basically create an instance of the entity type. So it's off that change tracker entry.
Yep.
Okay, let us go here and talk about, so what's missing? And there's a lot of functionality missing. So when you're making that decision of going with the EF Core provider, the SDK provides a lot of capabilities. The EF Core provider does not. These are some of the top voted ones: support for collections and dictionaries of primitive types. Include support, I'm not sure that's even in the SDK, but it's requested a lot. From SQL support, time to live, serialization options, data migrations. Now, half of these, half of these are on the roadmap for EF Core 6. And that's actually the last thing I wanted to pull up is our EF Core 6 roadmap. So this is something we do our planning out in the open. And you can easily, let me show you how I get to this. Ooh, no, I don't want to close my StreamYard tab. That would be very bad. Okay, so what I did is I went to, let's zoom into the top. I went to .NET EF Core issues. So that was my entry point. And I basically just filtered to the area Cosmos and the milestone 6.0. You can see there's 25 open issues. Now, this is not a guarantee that these will be present in EF Core 6, but this is a what's the right word I'm looking for, Arthur? This is our...
So when we do planning in public, we're giving you the information we have, and so best our estimation abilities and incoming work and all the other things that are involved in planning software projects. This is what we think we're going to do, but very likely we could be wrong. We could pull in something else because we realize from customer feedback we really need to do that. That might make us bump one of these out. We could just find one of these is overly complicated and have to punt it because of that. So rather than take the old Microsoft approach of just not telling people anything because we don't want to ever take back that we said we were going to do this, we're giving you the best information we have with the understanding that this is software, and we can't crystal ball everything's going to happen in the next few months, and so some things may come back, and we may have to pull them out.
So we are close to time. Let me just pull out a few highlights to talk about what's coming, and then the whole reason for sharing this is it's actually a call to action for our viewers, because if you're interested in using Cosmos DB with EF Core, we need to hear from you what we can do to make that experience the best, and you can do that by upvoting these issues to let us know that they're important. And you can also do that by filing new issues if there's a piece of functionality that's not there. What we've got slated, implicit ownership. This is turning out to be a huge, I think, change, because in the relational world, there's implicit non-ownership, right? So you explicitly configure that. We are looking at the option of, if I have an entity, we assume all its complex types and properties, et cetera, are just part of that document. So that's one change that I think will be very impactful for people using it. If we come down here, partition key on join entity by convention. This is a performance enhancer and a cost saver. Optimization of queries, who doesn't want that? Detect partition key filter. So this is more of understanding if a query has the opportunity to work on a particular partition, do what we can to make sure that happens. I believe I'm getting that right.
Yep.
And then from SQL support, right? We talked about that ability to drop down. So if there's some type of SQL that you can't get working through the link conversion, to be able to have that raw from SQL that you create is another one. Time to live per entity, consistency level. That's a whole other topic, right? How consistency level works. But Cosmos DB allows you to specify a default consistency level, and then you can override it per transaction. So adding that support. Aggregate operators is, of course, important for rolling up analytics and functionality like that. And then this one, remove or internalize JSON.NET dependency. I think ultimately the goal, both from the Cosmos team and our team, is to allow you to use your own serializer for this. But we'll work with what serializer the SDK is using. So that's the roadmap, the snapshot. I'm going to stop there. I don't know if Arthur or Shay have any closing thoughts or comments, but yeah, hopefully. Oh, go ahead.
I have one thing to. It comes back to what we were talking about right at the beginning about pits of success versus pits of failure being the opposite. And so when we're looking at that feedback from people, we're also trying to understand which things, if we implement, will end up being a pit of success versus a pit of failure, which is particularly relevant, for example, with include. So if we let you just write a massive chain of includes, like people like to do, which essentially then will bring back your entire Cosmos database through, very inefficient means, it's going to cost you loads of money. It's going to be very inefficient, and it's really an antithesis of what Cosmos or a document database is about. So we're trying to be careful about not just saying, hey, people are clamoring for this, but also saying, well, if we do that, are we going to basically leading people in a pit of failure? And so that's kind of the challenge we have in balancing this, providing the functionality, but not making, and I think we can all look back, if you know the history of EF Core and look at the client evaluation thing, it's an example there where we did that experiment and ultimately we reverted it because it was basically, there's a bunch of reasons, but one of them was it was too much of a pit of failure. We went into it knowing it could be, and our experience has been we can't protect people from that, right? And so we're aware of that, and it's very much on our minds when we're looking at how we implement Cosmos as well. So I just wanted to say that.
Awesome. Well, thanks once again, everyone, for your time and attention. Be sure to...
I'm going to call out here Andrew, because, Andrew's done most of this Cosmos provider. He actually joined us on the compiled model ones, which is unusual because this is not his thing, but many thanks to the people who do the work. So many thanks to Andrew for writing all this code.
Yeah, so someone said it looks like he causes most of the issues. He's getting deep into the code base and filing issues as he sees opportunities to improve the provider. So good stuff. Thank you, everyone. We will see you in 2 weeks' time.
Thanks, everyone.